Welcome to the ADVizE mini lecture, Exploratory versus Explanatory Data Analysis. I'm Kristen Hunter-Thompson. So, like always, before we jump in, what are some initial thoughts on data analysis? What do you think exploratory data analysis means? What could it be? What does it make you think of? And how could this be similar or different than explanatory data analysis? Okay, pause the recording, think about that for a bit, and then come back. So, data coming in can be exceptionally overwhelming for our brains. It can feel like we are drinking from a fire hose. Data, 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 data. And then on the other end, we're like supposed to figure out what it means and what we want to say from it. Let's unpack this a little bit. Let's think about how we can make this feel a little less like a fire hose and a little more manageable. So, when we're working with data, the process of data, it's really helpful to initially explore the data we have to help us generate some insights. So rather than just like, whoa, this intense fire hose of lots of information coming at us, let's kind of get a quick sense of like, what's going on, sort of narrow our focus a little bit about what it is, what are the pieces we need, what is it we actually want to be doing. What does this look like? Well, this is to help us get familiar with the data, to make sense of the data. So here's an example where Cole Mathlick just plotted just an initial plot of survey responses. So she has no idea what the survey respondent said or what this might mean or what story she wants to tell from the data, but just like quick and dirty, like satisfaction loss by things gone wrong. All these were the different options, and this was sort of the percent that said less than very satisfied, and this was the percent that said very satisfied. Is this a good graphic? No. Is it helping us understand what's going on in these survey data initially? Yes, absolutely. We're just getting a quick sense of what is involved. We need to know what we're actually looking at. So here's an example of a graph put out by the New York Times, where you're thinking about number of pitches per game. That's what each of these dots are. Okay, so we get a sense like, okay, the league average is this blue line, and then we can interact with it a bit to change up like which team we want to look at. We have a sense that this is the number of pitches. We have a sense that we're looking at time. And here we're just looking, we're like, okay, what's going on? What's happening here? So when we're doing exploratory data analysis, some questions that we want to ask ourselves are, is my summary statistic hiding something? Remember we talked about, we want to look at all the data, the normalized data, not necessarily the summarized data when we're doing our initial exploration. Summary statistics are great. Summaries, percentages, averages, things like that are fantastic once we've looked at the data, because they can hide some things. And so thinking about like, what is it hiding? Do I need to go back a few steps? Do I need to look at all of the data? Or is this summary statistic actually great? Can I continue forward with this one? What's the appropriate frequency? How much data do I need? Do I need to look at? Do we need to look at every game in the Major League Baseball from all of those years? Or can we just look at some of them? Can we just look at a couple teams? That's frequency. How do things vary or not by category? Are the number of pitches varying by teams? Does that matter? Are they varying by decade? Does that matter? We can start kind of asking those questions and playing around and tinkering a little bit as we're exploring the data. Where are things different from what we would expect? This is a key one as we're exploring the data. We don't need to know the answer. We just need to ask ourselves that question and look at the data to do some exploration of, are they different? Are they the same? Are they similar? Are they dramatically different than what we were expecting or what we would have predicted? And then this is another key one. What assumptions am I making? As I'm looking through these data and I'm starting to get a sense of what's there, am I drawing any assumptions right off the bat about my sample, about the pattern that I'm starting to see, things like that? Asking this question early is fantastic rather than all the way at the end. where you're like committed in strong as to what your story is, then it can be really sad to kind of give that up. So exploring helps us get a sense of what's there, some insights of what's there, to narrow our focus of what it is we want to look at. But then we want to like kind of dive more deeply in, do some deeper exploration, figure out, okay, what is it I want to say? What is the meaning that I can find from these data? It helps us share the insights. Explaining with the data helps us share the insights to show something specific. So rather than just, I'm just going to plot everything and just tell you kind of what I looked at, now Cole Knaflick is saying, okay, so the top 2 issues with the highest percent of non-complete satisfaction are both steering wheel related. And she's bolded them and made them stronger to make them pop out here. She's got something specific that she wants to say from these data. Similarly, the New York Times, strikeouts are on the rise. That's what they want you to take away from here, where they've got some annotations in. There are more strikeouts in 2012 than any other time in Major League history. They want it to pop. They've got something. They've done the exploring. They've decided the story that they want to tell, to share with you. So when we're putting together our explanatory visualization, when we're through the exploring and figuring out the story and we want to get into the explaining, this is when we want to ask our questions like, what level of polish, how fancy, or what do the aesthetics of the visualization look like? And put some time and focus on there. What biases might our audience have that will cause them to buy in or resist? Now, this is really important for data visualizers. It's a little less important for our learners, but it is still important for our learners to think about, who am I showing this to? Sometimes it's just us as a teacher. Sometimes it's to their peers. Sometimes it's to their parents or their uncle or their grandparents or their school board. And I recommend as much as possible, we get our learners early on thinking beyond, I'm just doing this for my teacher because my teacher is asking me to do it. But think about, who else could the audience be? And think about how that might land, how they might enjoy or not the visual, the story that they are telling from the data. What will the visuals show? How do we construct it? How will I be presenting? Will I just be printing it out on paper? Will I be drawing it out? Will I be handing it to them? Will I be talking to them? And who can give me good feedback? This is one that we could really pull in more and more into our classrooms as our students are building their learning with working with data. As we are building our learning working with data, here's the deal. Almost every single major news media outlet right now has a data visualization desk team. And that's not just because there's so much work, that's because there's so much value in getting feedback from one another, regardless of how old we are. Collaboration and feedback is the key to the game. So in this series, as you may have noticed, but as we're continuing to work forward with ADVizE, we are really focusing on this exploratory side. We're thinking about asking our questions and how do we refine our questions and make sure they're really testable, producing the data, either we're collecting the data or we're accessing the data that other people have collected, processing the data, organizing, sorting, filtering, preparing that data set to make visualizations, and then we are creating and iterating visualizations. All of these components land fully in the exploratory data analysis piece. This is not to say that explanatory data analysis is not important. It absolutely is. It's just, there's a little bit more of that already in the K-12 space, and the exploratory is a precursor. So we're landing there. So that's where we decided to land. It's important, it comes first, but is it really used that often in the real world? Well, let's think about this. Welcome to a Slocum glider. These are all over the world. People use them, scientists use them all over. Those that study oceanography, they are fantastic because they are not attached to the boat and they are a lot cheaper than humans to send out into the ocean to collect information. the way that they work is that they have this nose cone and they can pump out or suck in sea surface, like seawater. This is my gross simplification of how it works, but that changes the density of the buoyancy of the Slocum glider. And so that it can go through, oh, it's not going to play for us, so that it can go through and go in this seesaw format as it is going up and down through the water column to collect information. It sends that information back via satellite to the researchers wherever they are, and then they can plot the data and figure out what's going on in the ocean. So when the scientists drop the gliders into the water, they can then direct them, give them directions, and you can get a track that looks like this. So the scientists have told it to turn west and then north and then east and then north again. First it was going south. This is the southern, off of Southern California. So this is what a glider track looks like. And then when the glider comes in, when they're analyzing the data, it creates something that looks like a profile like this. So just a little bit of orientation to this profile. We are looking at water temperature in Celsius from 1 to negative 1.5 degrees Celsius. And we're looking at the ocean. And so oceanographers often go from the surface down. So we are in that bottom right-hand quadrant of the typical math 4-quadrant space of graphs. So 0 is at the top, and the larger negative numbers as you go farther into the ocean go down. And so Dr. Felipe Carvalho was studying this and was interested in this spot right here for her PhD. She was interested in looking down in Antarctica. That's why it's so cold. It's really helpful to send these instruments into the water in Antarctica so we don't have to get people out there. But she was really interested in this sort of elbow or hookup. It's called the mixed layer depth. It is very common. It's found all throughout the ocean. And she was really interested in, so on January 11th, it was here at about 25 meters. And then on January 19th, it was all the way down here around 70 meters. So like, what gives? What's going on? Why? What is driving where this mixed layer depth is, and how can it change so quickly? So she was really interested in looking at this across the summer season and across a couple seasons to get a sense of like what might be influencing this. So this is what initially comes out from the gliders. But if she's looking across multiple years of the summer season, can you just imagine how many of these individual little graphs that she would have? That's not going to work. So the first thing that she did is she plotted all of the data. So this is every single data point that she had at that point in the data set to play with. But then she remembered, she was thinking, she's like, okay, but I don't actually really care about the year because I'm just interested in looking at the summer season. So then the next set of plots that she made was the daytime, so month and day, and then the depth of the mixed layer. She went in and looked through all those profiles and figured out where the mixed layer depth was. And then what was the average temperature at that mixed layer depth for that date and time. And she's like, but I really want to see, how do these interact with one another? So then her next question, so then she made a graph to be like, okay, so how do they interact? So here we have the mixed layer depth. We're still going surface down, even though they're no longer negative numbers. We've got the month day, and then she colored the dots based on the average temperature to try to see what could the relationship be. And she was like, okay, now I've looked at all my data. I'm really interested, but there's a lot going on. What happens if I average it? So she took a daily average of all of those values and put them together. And then she was thinking, right, we can't have a naked average. We have to indicate the amount of variation in the data. So she calculated the variation by standard deviation, and the mixed layer depth standard deviation is with these whisker lines, and then the standard deviation of the temperature is by the size of the dots. So then she's like, okay, so now I'm starting to see some things going on in the data, but I'm curious how this relates to wind speed. And then actually, I'm curious how it relates to wind speed, surface radiation, dissolved iron, and our average salinity. Oh my goodness gracious, so many things going on. So, but what I want to share is this is the published figure. And Philippa, as she was going through, this is a chapter of her dissertation, as she was going through all of those graphs that I just showed you and that story I told you of how she was making sense of the data, that was her exploratory data analysis. That was how she made sense of the data, worked through it, iterated it, made a graph, thought about it, got feedback, went back, made another graph, dug a little deeper, dug in. She was refining and going deeper, deeper, exploring to figure out what she wanted to say in her final figure. This is no joke. Exploratory data analysis is really important, and we all do it every time we're working with data. So give yourself a pause and make some space for exploratory data analysis. The questions to think about at the end of this mini lecture are, how did the ideas or information that I just shared, that we talked about, connect to ideas you already thought or knew about data analysis, about making sense of data, about exploring data, making meaning from data? How has your thinking been extended, taking it in new or further or deeper directions based on what we just talked about? And then finally, what are some challenges or puzzles that have come up? What are some questions that you've got about this topic, about what we've talked about here? Where you're like, okay, but what about? What are some of those questions? So pause the recording, think about that. I encourage you to jot some notes down. Remember, it's always better when we jot some notes down, or at least draw a picture, something, or say it out loud, also totally works, to think about this reflection about exploratory data analysis. Okay, before we wrap up, as we're going into thinking about making our data visualizations and creating more time for exploratory data analysis and thinking about working with data, the process of data, making sense of data, I want to leave you at this. First think, then act and create. Take the lesson from Wile E. Coyote. We so often, because we're time limited and there's so many other things we have to do or want to do, or it's super, super late at night and our homework's due tomorrow, we often just want to like jump right into acting and creating. But taking that pause to think can be really helpful. And in fact, when you're putting together a visualization, you could think of it something like this, where you take some time to do some prep, you kind of talk it out, think about what you want to do, either talk to yourself, you can totally talk to yourself, that's fine. Ideally, talk to another human, also great. And think about like, here's some ideas, and then we sketch it out, and then you make the visualization. And while it can feel like this will take a lot of time, your end product will be better, I promise. And all of this prep and talking and thinking and sketching is going to help you in the long run get to a stronger end product that you're working on, even if it's a prototype, even if it's an initial draft. So just wanted to share that with you. As always, thanks so much for participating, for joining in. If you've got any questions, I'm happy to answer them. Just reach out to me with this contact information. Have a wonderful day. Enjoy exploring your data.